Next, we have a panel discussion on the topic IIoT, revolutionizing industries towards precision and efficiency. Industry leaders successfully use IIoT devices to expand their firms and keep ahead of rivals. And why shouldn't they? After all, IIoT is a crucial element of corporate survival for those who want to maintain relevance and stay in business despite digital disruption. From my point of view, one of the biggest challenges at the moment is spreading awareness about the metaverse and all it has to offer and educating people on how it works. This panel will discuss how IIoT enhances productivity and reduces costs across several industries. Sit back and enjoy this next topic as I call the subject matter expert, Mike Wehrs, the business strategist and tech leader at Unidata Limited, who will throw questions at our panelists. Guan, the CEO of LGTECH Inc., and Jonathan Pollet, who is the CEO and founder of Reg Tiger Security, as well as Garrett Temple, the founder and CEO of Novogiene, to get the most from this session. Welcome all those panelists to the stage.
Good afternoon, everybody. I know we're the session one after lunch, so hopefully the sugar high has died off and coffee's right and everybody's good to go. We've got a great group of panelists up here, and I don't want to take a ton of time. I want it to be as interactive as we can get it. So what I'd like to do is just kick it off with quickly 1 to 2 minutes, just introduce who you are and who your company is. And then we'll get into a little bit more depth in the topic. So Chi, if you want to kick it off, please.
All right, my name is Guan, and this is my co-founder, Kenneth Lang. We founded this company called LGTECH in Los Angeles to create the decentralized, distributed infrastructure for IoT business.
My name is Garrett Temple. I am the founder and chief executive officer of Novogiene. We are a medical technology company focused on epidemic prevention.
Hi, my name is Jonathan Pollet, and I'm the CEO and founder of Reg Tiger Security. And we've been working in the space of cybersecurity and risk management for almost 20 years. So I'll be speaking about how the Internet of Things have been adopted into the industrial space for factories and automation.
Great, so thanks. Just briefly on me, my name is Mike Wehrs, is the person who introduced me. I'm right now incubating 2 different companies, so I have a glutton for punishment. One is called Unidata Limited, and that's in a supply chain capacity. And obviously there's a lot of security implications in that too, because we have access to a significant amount of information up and down the supply chain. And the other one, totally unrelated, but equally you can see security implications as well, is around a whole new way of understanding how the affiliate network works for online gaming. And that company is called BetX AI. Both of them are pretty AI dependent. So with that, I think I'd like to ask Jonathan, if you wouldn't mind, to kick us off a little bit here. And could you frame the space? I mean, the way that you described your knowledge and experience to start with, really, I think it would be good to give us an overview of how you see the space.
Sure, thanks. So I started in the late 1990s programming industrial control systems for big factories. So back then, if you wanted to produce a product, there was a very large cost involved to develop and install a very huge distributed industrial control system of plant equipment that all had to be connected together and programmed. These systems were very large and monolithic, largely not connected to the internet, or if they were, they had several firewalls between these large control systems and the internet. As we see time go by until the current time, there's a lot of reasons why we needed to connect these factories to business analytics systems to gather the information from these systems for marketing and trading and to make your factories more efficient. And vendors found it increasingly difficult to get connected back into the control system from the internet to work on the systems or to troubleshoot the systems or to provide meaningful diagnostics for the users of their equipment. So as the technology in our world starts to miniaturize, Now we have little tiny Nest thermostats in our homes that have a full computing power in them that's controlling your temperature in your house, for example. So the whole topic of Internet of Things is basically any computing device that's not a mature operating system like Windows on a computer. So a small embedded device that's doing a very specific function or task, whether it's controlling the temperature in a room or it's monitoring the water analytics in a water plant to make sure that the water coming to your home is clean. So these Internet of Things started creeping into the industrial space because factories wanted to glean more intelligence from these systems, and the vendors were happy to snap in a lot of these devices that kind of added additional capabilities to their industrial control system. So now you'll see places like Walt Disney World. If you go to any of their parks, there's probably over 100 different systems at that park that are IP connected through various means. Many of those are industrial Internet of Things devices. And if you look at this year, 2022, there's over 15 billion simultaneous connections to the internet from Internet of Things devices, and it's projected to go up to 27 billion by 2025. So now we have a large attack space of all these devices that were before hidden behind firewalls and doing their own little thing. Now in every space in industry, medical, chemical, airline industry, almost any industry you can think of has these tiny little Internet of Things devices. And the challenge is, how do we manage all these disparate systems? How do we provide authentication to these devices? How do we secure access to these devices in such a way that the people that want to use these systems gain the benefit of them without the threat actors getting a hold of these things and hacking systems through these Internet of Things devices? Now, the positive side of Internet of Things explosion into these industries is that smaller players can now get into the marketplace. If you are a smaller print shop, or you manufacture a certain type of product, you no longer have to deal with this large investment in a monolithic control system. You can just deploy a smaller Internet of Things skid and get into the marketplace quickly to provide value to your customers and to compete with their larger manufacturing companies. So it's an exciting space to be in. Hope that helps give you in your mind kind of what we're talking about this session, and I'll turn it back over to Mike.
Great, thanks. And we can just, Garrett, you want to hold on to it?
Oh, okay.
I think Jonathan just covered it really well from here's the overall look of it, and then from the industrial side. But if you could add in medical and healthcare, well, you've got a deep background, that would be great.
Absolutely. Well, one application right now for Internet of Things devices in the medical industry and in health and wellness is we have smart monitors for patients. So a doctor no longer needs to come into a room, look at the patient's chart. They can come into the room and start discussing with them what the charts say because they read it on an iPad out in the hallway. And we're going to see more and more IoT applications, I feel, in the medical industry and in health and wellness as we start to move into the space of augmentation and implants. Like, we're going to see things like internet-enabled pacemakers and other implants, which is going to represent a whole new issue in terms of security, like Jonathan said. I mean, do you really want to think about if somebody could hack a pacemaker and what that could do to a person's heart? No, that's why there's a need for security in IoT right now, so that when we get into the future, we'll be prepared. We'll know what to do, especially in very sensitive areas like medicine, like healthcare, where you are literally dealing with a person's life at stake.
Really good, and nice transition. So Chief, if you could take it from there, we've kind of had the application story from two different sides, but all of it in the end does boil down to the devices, right? If we can't get the devices secure, if we can't get them at a cost point, if we can't address how come we would do this as a direct connect as opposed to going through the cloud architectures and the security implications of end to end, but that's all at the device layer. So being that you guys are in the device space and in that protocol layer, could you talk to how you're thinking about that problem?
Sure. We're not at the device layer, but anybody that go on the internet has to use the cloud, right? The cloud basically is the roadblock of the IoT business for right now. First of all, it's very centralized. They use the client server model, and then they use it's not a direct communication between devices. They're not. And then first of all, like security, they're not secure. Remember AWS? was shut down last year. I mean, they're not secure. Talking about privacy, you don't have any privacy. The cloud control and monitor every data you have right now. And then also, the developing curve is very deep, and you have to hire high pay engineers to develop on the cloud. Now in with LG Tech, we patent this technology called the LAN platform. We decentralize the cloud, so everything is peer to peer, and then we solved all the pain point of the cloud. So now the small companies can say goodbye to the cloud providers. First of all, it's very secure. Why is very secure? Because we don't use client server model. Everything is client based, peer to peer, talk to each other. No server open the port to the world, no nothing. And second of all, very private, like the patient data and everything, very private. No other cloud monitoring you, right? And then the third, our cost is very, very low compared with the cloud services.
How low? That-
2%.
Very low.
Yeah, 2% of the current cloud services. And then our SDK is very easy to learn. You don't need high paid engineer to do that.
I can add to that.
Yeah.
I can add to Guan because I'm one of the first founder here. I'm the engineer and also the technologist myself. I help many companies to develop IoT products using the AWS, the Azure, and the Firebase platform. After we developed the product, we experienced a lot of issue, which we call pain points. That pain point is associated with the firewall, associated with the HTTPS protocol, which is not secure, and also associated with the client server model, and also associated with the cost that we have to pay to AWS, to Azure, and to Firebase, Google platform. Since that, we decide to figure out how to solve this pain point problem, which we call as a layer 3 networking OSI problem. So how do we solve this? We create the virtual layer is called 2.5 layer between layer 2 and layer 3. Layer 2 is the data layer. Layer 3 is the network layer. And all the application, which is the device you're talking about, or the control app you're talking about, is on layer 4, 5, 6, or 7, which is the presentation layer, session layer, or the application layer. So because of that, you have to go to layer 3, no matter how you look at it. And anytime you go layer 3, you have to pass to the firewall. You also have to pass to the router. How do the cloud computing accomplish that? Either you have to have an indirect communication between the device and the controlling app by sending the data to the cloud. The cloud will be the temporary storage holder for you. So the device collect data, sent to the cloud. The application communicate with the cloud to get the data. And all of that, what we call is the request and response mechanism. So talk about if you want to deploy million devices around the world, you talk about you have to send out million client requests and response every second. So we calculate that. And actually we experience a lot of costs here after we deploy the product. So I basically help the small and medium company to develop many different products. After we deploy, they all fail. For the matter of the public here, I cannot disclose that information. But G and I would pioneer this patented technology, which we call is a Lantern platform. This platform basically provides you the SDK, so you can integrate into your product as a layer 2.5, which is the virtual layer, and it will be created on demand. So as more devices connected to the internet, this layer will scale based on that demand. And the cost of this will be just the fee you pay to use our platform, which we have one present at this point in the LA data center. At this point,
Cut you off a little bit. Okay.
for the time constraint, I cannot disclose more, but I'm glad to share with you any more information.
So we've now gone from cloud-based solutions to get rid of the cloud because we can go in and do things a lot more efficiently without it. What are the implications at the industry level and kind of at the healthcare level if you didn't have a centralized monitoring point and all these things are kind of peer-to-peer? Are there liability considerations that have to be worked out, or what kind of changes would that make to the way that you guys think about it?
That's a very good question. I have to think about that for a second, but the easiest answer I can give is if healthcare and medicine were to move away from the cloud platform, from that centralized structure to something more decentralized, where say each facility has its own infrastructure, then one, I think it would be better for security because there's not a large target out there with a big bullseye on it in terms of the cloud infrastructure, cloud architecture that's being used, and the facilities themselves have more control over how things would be built, how things would be managed. But that also presents a problem because what exactly does the hospital's IT department know about security? And what do they know about architecture? What do they know about construction of these kind of systems? So it really does raise concern with that. And if they are using things like smart monitors or say internet connected implants, to once again use the example of the pacemaker, that represents all kinds of threat vectors that could be used to then attack what the hospitals, what the facilities are using for managing their systems, for storing their data, for really everything. So there's really no easy answer.
Did you have anything you wanted to add to it, Tom?
I would fully support that, and I agree with this philosophy, because before in these larger monolithic control system environments, these systems were isolated from the internet and all being maintained together. But however, now they're all individually going out to the cloud. So you have thousands of devices going directly to the internet. And so if I wanted to have something implanted in my body, I would personally would like the ability to turn off its ability to connect to anything. And then when I need diagnostics, turn it back on. So the concept of introducing security down to the device level, I think, is also going to be coming back in the future. Also in the car industry, so many of you are aware of self-driving cars, Teslas, all your cars that have OnStar are connected to the internet. It would be nice if I were driving a car like that to know that it's not connected to the internet right now. And when I need to do a flash update, I'm in control to turn on that internet connection or not. So there's a lot of things to think about with Internet of Things, a lot of things to think about. But certainly, we specialize in cybersecurity and we have deep domain knowledge in industrial systems. And if you guys have any need with integrating these things, that's what we're here for, is to help implement these solutions in a secure way.
I can share my idea with that security using our technology. That is our technology. We don't collect data. So basically there's no client server. So for the patient information, that will be safe. And as far as for the connectivity, network connectivity and data connectivity, security, and those kind of issues, using our technology is also safe at that point. Because for the network connectivity, we don't have client server in the cloud. So the device don't have to post data to the cloud. The application also don't need to request data from the cloud. So for data security, that is secure. And now talking about the data security at rest and in transit, we can encrypt the data end to end because this is peer-to-peer technology. So the app can communicate with the device directly in the peer-to-peer fashion using our platform. I think that will be add more to the security.
So John, let me ask, Mike, let me ask you some question. You have, like these two venture that AI plays the roles, right? What do you see is the role in the IoT?
That's okay, I can talk.
Yeah.
Sure. It gets a little bit abstract, but I think the easiest way that I can get my head around it is, for AI to do its job, I need lots of data coming into it. Right now, if that data is coming in through data sources that we consider logical elements already captured from some other purpose, like data that's been ingested, data that's been input, or otherwise screen captured or whatever, That's a source, but everything with industrial IoT is just another source to me. So to me, I just kind of view it as an extension of I need as much data as I can get my hands on as often as I can get it in order to do the right thing with it to help make these models do better. So, for example, let's use the Unidata Limited company for a second as an example. If I knew that that there was a tsunami in that affected the agriculture in southern China, and there was a shortage of yellow dye, I know that 9 months before product that was supposed to be yellow is going to show up in retail. Now, if I could know that and not pass that on as a trade secret to screw with stock markets, but instead be able to say, retailer, the thing you want isn't going to be here and there's nothing you can do about it. Now, normally you'd have to wait till 2 weeks before it gets out of customs to find that out, but I'm giving you 6 months lead, order something else. Just think of the savings that could happen if we had that level of insight in what we were building. So I really do just view it as it's another series of input, but it scales beautifully, right? We're talking about thousands of devices. We went from how many connected devices in a home before all these Alexas and everything came out. You had, let's see, 2 computers and maybe 1 or 2 iPads and maybe your phone. Now people have 100 devices in their home that are all connected. That's a lot of information that I could be doing the right thing with and just trying to get the AI models better for Unidata. And for BedX, there's lots of things that can be done to help problem gamblers or to stop them or reduce the likelihood people can get themselves into trouble. If, for example, I'm aware that they've now just filed 3 different applications for more credit, I probably shouldn't accept a large bet from them, right? So maybe there are things like that that could be particularly helpful to stop people from getting themselves losing their entire fortune over it if I had a little bit more information. And this is why I look at everything in IoT. It's like, this is a great data source if used correctly. Now, could it be misused? Absolutely. But that's something we all have to be ethical about. We have to put protections in place to make it so that we don't have that. But it's shocking to know how much of that information is out on the dark web to begin with. So I'm really not taking anything that isn't there already. I'm just making it easier and everybody can do it above board and it's not all this surreptitious stuff. So that's kind of why I'm here and what I think about it.
So like you have built this mass adoptions, of this for example, the IIoT stuff, how do you scale it out faster? Like
Yeah.
yeah,
Good question.
yeah.
So I'm lucky. Earlier in my career, I worked at Microsoft, and I ran industry development for their whole mobile group, as well as a bunch of IT things and some other stuff. But the real question became like, how are we going to gain adoption for something that isn't just purely Windows, right? Because you have to be careful about what you pick. I was asked to look at what was going on in the mobile space, and I was one of literally 9 guys who came up with a way of getting Bluetooth from something that was a connector to replace your earphone wire to doing something more than just that. So and then it was mice and keyboards, and they blew up from there. And it all became from the key insight was if they don't have an IP connection, if they kept it a proprietary connection on how Bluetooth worked in the world, we would not have Bluetooth today. It would be an esoteric one-off thing. But because of the IP connectivity, we have, I don't know how many trillions of dollars in economic benefit the world has gotten from that. But it's all about the insights to how do you get this to market in a way to get to scale. And another really good example would be on mobile devices. This happened when I was at Nuance, and we were trying to get speech activation put on everybody's phone. It was before you could like talk to your phone and say, it was definitely pre-Siri, but even just basic commands like, give me a reminder, set a calendar appointment, any of that stuff. But I happen to be sitting on the board of directors of CTIA, which is a cellular telephony board. So I brought it up as a recommendation that if we don't get in front of this as a cellular industry, then we're going to get laws and regulation that say we're not allowed to use phones in cars. And how many people would like to see 35% of the total time people could be talking made illegal? That, or we could put this little bit of software in there that lets you be able to talk to your phone. And that really was the catalyst to come up with how do you get that one to scale? It was you needed regulatory support to force the manufacturers to do it. And then the carriers just came and just sprinkled their magic dust on it. And today there's not a phone you can buy that doesn't have the right kind of hands-free operation to be able to use it in a car. But that's it. find the application that's going to give you massive adoption early on. And those are two examples of how I did it in the past.
I would like to add something into that scalability using our technology. Our technology basically treat each of the device as a node, and the same thing as the server that we have in the data center to handle what we call as the discovery, switching, and connecting technology. So to scale out to support million device, all we have to do is just put another server in the data center, which to what we call discovery, switching, and connecting. Each of that server can handle 500,000 devices at the same time. So if you want to handle 5 million devices, we only have to multiply that by 10. And overnight, we have the server can scale out very quickly. It's basically literally overnight we're talking about. And that is the technology that we are coming up with.
Anybody else have any comments you want to make to what was just said? No? All right, I'm going to open it up for questions at this point. Yeah, please, I do ask everybody to come up and stand in the white square so the camera is focused. So if you haven't been chastised enough about that yet today, I'll do it one more time.
Thank you for the valuable insight. So when we speak about IoT, it deals with a lot of data, right? And it requires curation as well as, you need to figure out what makes sense and what does not. How do you categorize the IoT data and, work towards the, reduction of storage, because it's going to be like, it's going to grow exponentially, right? So how do you come out with a, strategy where you can take actionable data, and then what is your recommendation towards purging it?
Yeah, I think all of us are going to have something to say on that one. My comments would be you've got two different things you're balancing: power and how useful it is to have that kind of rich data there. So you don't necessarily need the rich data all the time. Sometimes you just need here's the point in time when a state change took place. So if you understand what the application and use of the data is, then you don't have to just send everything blindly to let someone figure out what they want to do with it. And the other one is, if you did do that, the power requirements on the device are incredible, right? So we're not talking about devices here that you want to have car batteries attached to. These are little things. So you don't want to crank these things up to start streaming video. Right? So anyway, please.
Yes, I would agree. So in the industrial control space in factories, all of these devices are connected to a common server, which then historizes it. So with the advent of industrial IoT, now we have multiple devices that are outside of this control schema, all talking separately to the cloud, to various different cloud applications that are bypassing this aggregator of data that is typically in a factory or in an airport or in a refinery, right? So in many cases, we find our customers don't even know what their footprint is of IoT. So for example, we did a very large project for Loblaws up in Canada. It's kind of like Costco here in the US, just to find out how much IoT do we have out there? Is it doing critical services for us? And is it protected? And where's this data going? And it was very interesting because we found over 700 devices just in one store alone that was talking to over 55 different applications, different cloud applications, and inside their business applications. So before you even get to thinking about what do I do with the data, I think the first step is understanding where is my footprint of IoT out there? Where is all this data going? And then where can I collate that data together into either a SQL Server, Oracle, or some type of historical database, and to glean the most benefits of it. So just getting your arms around where these devices are and what functions they're providing is really the first step to it, what we found.
I agree with the two gentlemen on that thing, but also I want to add my ideas on this about how to handle those massive amount of data. Yeah, with this technology that we have, we can consider one of the nodes in the data center as the way to store data. And as you can see, the equipment that we're going to use at the data center will be the utmost care equipment with the most cooling system, advanced cooling system, and all that. So we can handle those data at the data center just the same way as we do for the cloud computing using this technology.
So the way you briefed, you are introducing a layer 2.5 into the entire OSI architecture and pulling the data back into data center. How do you scale? I mean, you took cloud out of the equation, right? I mean, from a solution standpoint, I am curious to understand how do you scale if you want to, connect throughout the world.
Exactly, right? So this is how we're gonna scale. As more demand, meaning more device added to the network, the layer 2.5 will be scaled by adding more machine at the data center to handle the discovery, the switching, and the connecting of the device, of the IoT device. So that scalability will be go in and out, up and down based on the demand, based on the how many devices. And we have the software in the SDK to handle that at layer 2.5. In that case, it
So
will
you'll be
solve the
having
scale
data centers all over the world, like
all
in
over the world.
Russia.
Yes, because we can treat each of those switching center. Let's say if we deploy more than one present around the world, then we will have not only the redundancy, but we can also have decentralized, and it will be no points, no single point of failure around the world.
Yeah, that helps. Thank you.
Okay. Here's the way that the world of IoT and IoT works right now is people like add edge computing on their end, on the sensor end, right? So the edge computing down a lot of data already, right? So you think about it, this edge is one of the node on our network. So when you communicate to these edges, the things are going very fast. And then the data that goes to the data processing is going to be extremely reduced. You know what I'm saying? Yeah.
Okay, similar
Yeah.
to CloudFront, you are creating edge locations, and that's your data center. Is that what you're trying to?
Similar to cloud, except for the cloud, there's one issue. What happened in the firewall? So even at the cloud, you still have to open the port. You still have to open the port at the cloud for the data to communicate with the cloud. So you still have to have some kind of a layer 3 filtering, network setting in the cloud. With our technology, you don't need to open any port at all. So we basically penetrate the firewall, any kinds around the world. So we can hold the layer 2.5 for you temporarily only until we discover the device behind the firewall. We switch it. If you have more than one device, that's the reason of the switching. And then we connect. So as soon as we connect, we stay out. So that device and the app become direct connection, peer-to-peer at that point. So there's nothing can hack in between. Nobody can go in between to do like a middleman, concept or the DOS attack at all, because there's no HTTP, there's no HTTPS protocol involved here. So that's very secure. And more than that, if you want to even add more security into that, you encrypt end to end. From the app to the IT device, you encrypt the data.
Yeah, on transit and at rest, I get it. But have you ever come across any shadow sessions as you, keep an active session at endpoint versus your data center?
I'm sorry, can you repeat the question?
Oh, there is, probably security can answer, right? It's very easy to, create a shadow session when there is an active session available, and it depends on where we are going to inject that traffic.
That's,
So,
yes, to answer your question, that's what I did before with AWS and Azure. We have to create the shadow registry to store our data temporarily at the edge level and also as the cloud, so that we have what they call the twin technology, the twin brother. We did that. And we found out that even that is only help you in a non-real-time fashion. With this direct communication between the app and the IoT device we have, there's no need for the shadow data or registry data there. But if you want, you can still create that. You still can use that shadowing technology there at the edge or at the cloud or inside the IoT device or inside the app. So they all work the same way with this concept.
thank you for sharing.
Another mind-blowing conversation. Thank you, guys. I have a question for Chi, and that is with respect to all of the sensors being nodes, for example. So what's needed from the location would be the sensors and some kind of a router. That router gets to your second 2.5 layer, and then that's the end of the story. So we're not doing the firewalls, we're not interfering with the clients, anything else. Is that correct? We just need the router.
Right. You need a router or IoT hub.
Gotcha.
So you can go to the internet. So our technology is like, as long as you go to the internet, you're there peer to peer. But
Right.
how do you connect with the sensor is a lower level. How do you
Sure.
interface with the hardware? Like
Correct.
Bluetooth, Zigbee, whatever you want,
Right.
and then you can
Right.
do that.
Okay, so there's this distinction is between there's an internet and then there's the cloud. And
Right.
So
Right.
Gotcha.
You can get rid of the cloud as long as you get the internet. That's okay.
gotcha. Thank you.
I can add to that to answer that question for you. Is this if you have the device, the IoT device that cannot get access to the internet, then we need to have an intermediate nodes that we create using our technology. In that intermediate nodes, you install our SDK into that node, so that node can communicate with the IoT device that cannot access the internet. So that intermediate node there will be able to communicate with any device around the world, including the app to control the device. And that way you don't have to open any port on the router. Keep it, the same.
Does anybody else have any other questions for the panel?
I got a question really quickly. Okay, so I'm a diabetic and I have a system that pushes my insulin to me via Bluetooth. What I did was I went into Zero IoT, set up my parameters, then I communicated via VPN, but I was able to use Power BI to be able to kind of select triggers. So with your system, if it does not, is there any open API where a person can be able to customize, be able to create Power BI triggers to close or to alert me if something was a mishap or, everything is not foolproof. So I'm just kind of curious from a security perspective.
Well, I can kind of say, just based off what you've said so far about being diabetic and having a system to help you, you said it was to help you with insulin, correct?
Yep, it pushes it via Bluetooth.
Okay, so that's definitely something to really consider with not just that, but other implantable devices that are going to be IoT enabled or otherwise network enabled, is the ability to connect them to Power BI or some other program so that you can see the information for how well the device is performing, how well it's interacting with your body, just what needs to be put into it. And along with that, there's also the security considerations of what is your implant, your device talking to, what's on the other end, what is being transmitted along with that data, and what could potentially happen in the process of that data being transmitted from your body, from your device to whatever system is reading it and processing it.
Okay, thank you.
Are there any other questions from the audience? I guess one final set of comments from each of the panels, I think would be great. If you look back a year from now, and we got back on this stage, what is it that you'd like to have seen happen between now and then? So what would fundamentally need to change to make your businesses just explode? If you could script that, what would it be?
I would like to add my idea to this. This is the data privacy. The censorship is what I'm looking for if I have to look back a year from now. I would love to adopt the technologies that we don't have to censor, and also we can keep the data here instead of going around the world. So data privacy and censorship is my thinking.
I'm thinking we're against the monopoly here. So I'm thinking this is the shift of the technology region.
The biggest thing I'd have to think of is just ownership and the people being able to own their own data that they generate, as opposed to it being sent to a black box somewhere out there where it's not really clear what's being done with it and who's handling it and what purposes they're using it for.
I think I would summarize it with awareness. I think all of us in the room use internet connected devices more than we think, and we know less about what it does under the hood and who has access to that data. So I'm a large proponent for awareness, and I hope that a year from now, we can all be better educated on how we use Internet of Things devices and our own cell phones and other devices, and even in our home, and how to do it smarter and better. And I think awareness is going to be a big key to that.
And I'll share my own thoughts on it. It's really about avoiding the creepy factor, right? If you can use the information that you can have access to because it's been granted to you, and you do it in a manner that someone says, you know, I'm just getting less ads I don't care about. You know, it's okay. The minute though that it is, I think you need one of these too because you're a sloppy whatever, or you know, when it goes over that line, we're all like, wait a minute, rip everything out of my house. How do I get rid of this stuff? So setting that is part of who we are as a society, right? What's normal, what's acceptable, and what's creepy. Well, if we talked about what we do today 20 years ago, everybody thought that was unbelievably creepy, but it really hasn't killed many of us, so it's all right. But how fast we go can kill a technology or it can delay it decades. So we have to be careful about that. And I'd suggest just everybody needs a measure of get rid of some of the extremism on both sides. The tech is going to take a lot longer than anybody thinks it is to get where it needs to be. There's a lot of policy work that's got to go in. It's going to be wrong and it's going to be swinging back and forth 2 or 3 times. Accept it and figure out how we can do better at influencing the people who are writing the laws about what it really needs to be, as opposed to what one person who's doing an internship decides that they want to write, and the guy who's signing the law doesn't know anything about it anyway, right? So that just awareness, I think, is an important point. But just getting this stigma of it's being done in an irresponsible fashion, we all have to just step up and be much more ethically centered about how we're doing what we're doing and how we're disclosing it. And I think that would be that would be my wish for the world a year on from now. Any last minute question that came up? If not, I'd just like to thank all of our panelists. Great job, all of you. Thank you very much for your time. Thank you for all your questions and paying attention.